Welcome to Max with RP. Today we are going to explore competency based questions related to polynomials. Let's look at one such question. You are given two graphs h of x and g of x. So you can see the lighter shaped graph is h of x and the darker shaped graph is g of x. Okay, now you are given the information that h of x when divided by x minus 3, the remainder is k. That is h of 3 is k. You have to analyze what happens to g of x when divided by x minus 3. The graphs of h of x and g of x are given. This is a multiple choice question. There are options. Which is true for the remainder when g of x is divided by x minus 3? Is it less than k, equal to k, more than k? Or whether you cannot, give, it is inconclusive. You cannot conclude anything from the given information. Now, lot of things can be understood by just looking at the graphs. Now, if you look at the graphs, let us suppose 3 is somewhere here, between 2 and 4, 3 is somewhere here. If I drop a perpendicular, okay, now there is h of 3 here. What is h of 3? K. Where will it g of 3 be here? Because when I drop a perpendicular from the same point, if I drop a perpendicular from both the graphs, what do you observe? G of 3 is less than g of 3 is less than h of 3 equal to k. Therefore, the first option is true. It is less than k. You can just see it. This is h of 3 and this is g of 3. G of 3 is less than h of 3. Therefore, it is less than k. Now, this is a very simple question. It's a part of a graph given. So, we don't know where this is going to hit. On dividing h of x by which of the following will the remainder be 0? So, what is the 0 that you are observing? 0 is the point where the graph cuts the x-axis. So, x equal to minus 2 is a 0. So, what do you observe? So, if this graph, in the place of x, if you put minus 2, and if you call the polynomial as f of x, f of minus 2 equal to 0. If f of minus 2 equal to 0, then we know that x plus 2 is a factor. So, x plus 2 is a factor. So, here we do not know where it hits. So, this cannot be said, but we can surely say x plus 2 is a factor. Now, you are given a quadratic polynomial and you have to write another quadratic polynomial whose sum of zeros is less than that of the polynomial which is given. The given polynomial, let us call it as f of x. So, what are the zeros of f of x? Zeros of f of x are, where does it hit the x-axis? You can count and see minus 2 and 3. The zeros of f of x are minus 2 and 3. So, if I want to write a polynomial with these roots, then I know I can write it as x square minus sum of the roots into x plus product of the roots equal to 0. X square minus, what is the sums? 3 minus 2, 1 minus x. What is the product? Minus 6 equal to 0. This is one such polynomial. In fact, if I multiply this with k, this is what we also saw in the earlier video, then I can actually construct infinitely many polynomials with these two given zeros. Now, what is asked? So, this is given. So, what is required? You have to find a quadratic polynomial whose sum of zeros with sum of zeros less than that of the polynomial. For this polynomial, what is the sum? Sum is 3 minus 2. So sum is 1, right? So sum of zeros must be less than 1. So you have to find a quadratic polynomial whose sum of zeros is less than 1. So I can give many such examples. One, suppose I take the sum to be 0. Then x square minus 6 equal to 0 itself is a polynomial. I mean, it's when I write 0, it becomes an equation. If I just want a polynomial, it is this, right? Here also I have an equation. If I want to just write a polynomial, it is x square minus x minus 6 is a polynomial. This is an equation, quadratic equation. Now, so if I want to write a polynomial, I can write one such polynomial. I put 0 is less than 1, so this is x square minus 6. Or I can have one more example, example 2. This is example 1. I have taken sum to be 0. Now sum should be less than 1. So can I take sum to be say minus 2? Then let the zeros be minus 1 and minus 1. So what will be the quadratic? X square. What is the polynomial? Quadratic polynomial. X square minus sum of the roots. Minus sum of the roots into x. So plus 2x plus product of the roots, which is minus 2. So this is another example. So you can give many such examples. Okay, you can construct your own example. Maybe I will construct one more example, example 3, that s be minus 5. Okay, then let the zeros be minus 3, minus 2. Then what will be the, can I give as such a polynomial? X square, I will have what? Minus 5, minus of minus 5, so plus 5x. Okay, product will be plus 6 equal to plus 6. If I want an equation, x square plus 5x plus 6 equal to 0. So basically, I have given 3 such examples. It would be nice if you can create your own example, set of examples. Maybe as an exercise, you can try to write 3 to 4 such examples of your own. Now, look at this equation, x square, look at this polynomial. It's a quotient of 2 polynomials. X square minus 3 root x plus 4 by x minus root 2, where it is given x is not equal to root 2. Because if x is root 2, denominator will become 0. So that quotient will not be defined. Now, at how many points does the graph of the above expression intersect the x-axis? So let us consider x square minus 3 root 2x plus 4. Okay, now how can I factorize it? Minus 2 root 2x minus root 2x will be what? When I add, I will get minus 2 root 2 plus minus root 2 will give me minus 3 root 2. 2 root 2 in, minus 2 root 2 into minus root 2 will give me 4. So I have factorized this. This will be x into x minus 2 root 2 minus root 2 into x minus 2 root 2. So this becomes x minus root 2 into x minus 2 root 2. So the given, the quotient of expressions, polynomial expressions can be simplified as numerator is x minus root 2 into x minus 2 root 2 divided by x minus root 2. Now I can cancel off this only because x is not equal to root 2. If x were root 2, I cannot cancel. Very important concept in maths. You can't cancel 0 by 0 because it's indeterminate. Okay? So I am able to cancel only because it is given that x is not equal to root 2. So I am cancelling this. So this simplifies to x minus 2 root 2. So if this is x minus 2 root 2, what will be the 0? Let me call this polynomial as p of x. Okay. When I put, if p of x were equal to 0, then x minus 2 root 2 will be 0. That is, x is equal to 2 root 2. So 2 root 2 is a 0. So at x equal to 2 root 2, the graph will intersect the x-axis. That is the question that is being asked. At what point does the graph of the above expression intersect the x-axis? When x equal to 2 root 2. Are you able to follow? Is it clear? Now, two polynomials are shown in the graph below. You can see this is one polynomial p of x, and this is another polynomial, let us say g of x. Okay, now let us study the polynomials, okay, first, and then we will find the number of zeros that are common to both the polynomials. If I look at the first polynomial, say p of x, how many zeros does it have? It has got 2 zeros. If I study the polynomial g of x, how many zeros does it have? G of x also has 2 zeros. But if you look at the number of zeros for p of x, this is 1 0 and this is 2. This is second 0. If you look at g of x, this is the 0. This is the 0 for g of x, right? So how many is common? Common is only root. The 0 2. The 0 2, which I have indicated as 2, is only common to both the polynomials. So what we understand is each of the two polynomials p of x and g of x has 2 zeros, while 1 0 is different for both p of x and g of x. This is for g of x and this is for p of x. For p of x, where does it cut? Here. This is 1, first root. So if you look at this polynomial p of x, the zeros are 1 and 2. If you look at the polynomial g of x, the zeros are 3 and 2. Let me call this as 3 and 2. So the p of x has 2 zeros, 1 and 2. This has got 3 and 2. So 0 2 is the only 0 which is common to both the polynomials. Is it clear? You can see this is the only point where they intersect, and both of them are intersecting at the x-axis at the same point. Now p and q are zeros of the polynomial 2x square plus 5x minus 4. Without actually finding the zeros, that is, I am not going to solve and find, I am not going to equate it to 0 and find the values of x. You have to find the values of p and q and also evaluate 1 minus p into 1 minus q. So this is given, this is to find. Now from this, without evaluating, we know the relationship between the coefficients and the zeros. Sum is equal to minus 5 by 2, product equal to minus 4 by 2, which is minus 2. So what formula we are using? Minus b by a, here it is c by a. Now let me simplify this. Okay, now sum is equal to minus 5 by 2, product equal to minus 2. Now let me simplify this. So what are P and Q? P and Q are the zeros of the polynomial. So when I say sum, P plus Q. When I say product, it is P into Q. Now when I simplify this, what will I get? 1 minus P minus Q plus PQ. This is 1 minus of P plus Q plus PQ. So 1 minus, what is P plus Q? Minus 5 by 2. So this becomes plus 5 by 2. What is the product? Minus 2. So the polynomial, this whole expression is equal to 1 P plus this is 1 plus 5 by 2, because P plus Q is minus 5 by 2. Okay, so minus of P plus Q, right? So minus of minus 5 by 2 is plus 5 by 2, which is minus 2, which is 2 plus 5 minus 4 by 2, which is 3 by 2. So without solving, we are also able to find the values because we know the relationship between the zeros and the coefficients of a polynomial. Now a polynomial is given by Q of x. Q of x is given to be x cube minus 2x square minus 9x plus k. The sum of the two zeros is 0. So how many roots will it have? What sort of a polynomial this is? This is a cubic polynomial. How many zeros it will have? 3 zeros. Maximum of 3 zeros. There can be repetition, but it will have 3 zeros. Now what else is given? The sum of two zeros is 0. So let sum of two zeros is 0. So let the roots be, if one is alpha, the other one will be minus alpha, because alpha minus alpha is 0. Third one will keep it as beta. So let the roots be alpha minus alpha and beta. We have to use the relationship between the zeros and coefficients to find the zeros of Q of x, and also we have to find k. So two things we need to find. To find zeros of Q of x and the value of k. Okay, now what do we know? The roots are alpha minus alpha and beta. So sum of the roots, which is alpha plus minus alpha plus beta, is equal to minus b by a, which is equal to 2. Therefore, beta equal to 2. Because alpha minus alpha gets cancelled, beta is 2. Therefore, the roots are alpha minus alpha and 2. Is it clear? Minus b by a. So 2 by 1. A is a coefficient of x cube. So if I use that, I get it is 2. Alpha minus alpha is 0. So beta equal to 2. So one root we have already found, which is 2. Okay, now how to find the other roots? We also know alpha into minus alpha. That is sum of the roots taken 2 at a time. So I will get minus alpha square plus 2 alpha, right? Minus alpha square plus 2 alpha minus 2 alpha equal to, what is the c by a? 9 equal to 9. Are you able to follow? What is the formula? Alpha, if there are 2 roots, there are 3 roots. If you look at the sum of the roots taken 2 at a time, then that sum is always equal to c by a. So here c is minus 9. A is 1. B is minus 2. So I am taking two of them at a time. Alpha into minus alpha square. Minus alpha into 2, minus 2 alpha. Alpha into 2 plus 2 alpha equal to 9. So this gets cancelled. So I get minus alpha square equal to C equal to minus 9. So alpha square is 9 or alpha is plus or minus 3. So the roots are 3 minus 3. Beta we have already found, it is 2. These are the roots. Now what is it you have to find? One more. You have to find the zeros we have found. This is the zeros. We have to find the value of k. Now k, what involves k? Product of the roots. Product of the roots equal to minus d by a. Okay, which is minus k in this case. So now what is the product of the roots? 3 into minus 3 into 2 equal to minus k. So k equal to 18. 3 into 3, 9. 9 into 2, 18. Both of them have minus sign. So k equal to 18. So we have found the roots and we have found the value of k. These are the roots and this is the value of k. I hope it's clear. Next question. P of x equal to ax square minus 8x plus 3. Where a is a non-zero real number. A is not equal to 0. If a is equal to 0, it will not be a quadratic. So that is why these conditions are very important. One 0 is 3 times the other 0. So let one root be alpha. Then the other root will be, what will be the other root? 3 times this, 3 alpha. So if I add, what will I get? 4 alpha equal to 8 by 8. Sum. I am finding the sum of the roots. 4 alpha equal to 8 by a or alpha equal to 2 by a. Now, what else is given? You also know that the product of the roots. This is, we have used the sum of the roots. Product of the roots is c by a. Product of the roots is equal to alpha into 3 alpha is equal to c by a. What is c? 3, a is a, which implies 3 alpha square equal to 3 by a. Alpha into 3 alpha is 3 alpha square. C is 3. It's given here. A, B, C. C is 3. C by A is 3 by A. Or alpha square equal to 1 by A. This is equation 2. From here you have alpha equal to 2 by A. So I am substituting. From 1, if I substitute, substituting from 1 for alpha, we get, what is alpha? 2 by a. So alpha square will be 4 by a square equal to 1 by a. So 4a equal to a square. I can cancel off a because a is not equal to 0. A is not equal to 0. So cancel off a. So 1, you will get a equal to 4. So a equal to 4. So what is the value of a? 4. Now what is the shape of the graph? What kind of a is 4? So the quadratic will be 4x square minus 8x plus 3 is the polynomial. Now whenever a is greater than 0, We have already discussed, in fact, I have even shown it using GeoGebra. Then the polynomial will be upward. What will be the shape? It will be the shape of U and it will be upward. When A is negative, it will be downward. Since A is positive, the parabola will open upwards. It will be a quadratic polynomial is represented as a parabola, and if A is positive, it will open upward, and if A is negative, it will open downwards. Now look at the next question. We have f of x equal to 2x square minus 4x plus k. F of x equal to 2x square minus 4x plus k, where k is a non-zero real number. When f of x is divided by x plus 2, it leaves a remainder minus 14. F of minus 2 is equal to minus 14. What is given? When f of x is divided by x plus 2, it leaves a remainder minus 14. This is also factor theorem and remainder theorem which you have learned. And we are going to connecting that with polynomials. So f of minus 2 equal to 14. This implies 2 into x minus 2 square, which is 4. Minus 4 into minus 2 is plus 8 plus k equal to 0. So 16 plus k equal to 0 or k equal to minus 16. See, when it is divided by f of x is divided by x plus 2, right? It leaves a remainder minus 14. Remainder is minus 14. So please underline that. That means what? F of minus 2 is minus 14. So now I am substituting x as minus 2. Minus 2 square is 4. 8. Minus 4 into minus 2, again plus 8. Plus k equal to, 14. Not 0, 14. Okay. So this is 8 plus 8. 16 plus k is 14. So k equal to 14 minus 16, which is minus 2. So what will happen to f of x? F of x will be 2x square minus 4x minus 2. So what will be the zeros of f of x? So that is the question that is asked. That means when will f of x be 0? If it is 0, you will get x square minus 2x minus 1 equal to 0. This is minus 14. So I will have minus 14. K will be minus 14 minus 16 minus 30. So this will be minus 30. K is minus 14. The remainder is minus 14. I had missed the minus sign. So now from here what do you get? X square minus 2x minus 15 equal to 0. So what are the, when I factorize, what will I get? This is x minus 5, x plus 3 equal to 0. X minus 5 plus 3 minus 2. Minus 5 into 3 minus 15 equal to 0. So the zeros are minus 3 comma 5. The zeros are minus 3 comma 5. So this is minus 3. This is 5. Now we have finished the first part. Find the zeros of f of x. The second one shown below is a graph of f of x. The vertex is the minimum value of f of x and the dotted line through the vertex is the axis of symmetry. What do you mean by axis of symmetry? It is like a line, as if you have a mirror here, then this will be the mirror image of the other. So this will actually pass through the midpoint of minus 3 and 5. So that is what is most important. Axis of symmetry passes through the midpoint minus 3 and 5. So what is the midpoint? x1 plus x2 by 2, which is 5 minus 3, 2 by 2, which is 1. So this point is 1. Okay. So when this is x is, now what is this point vertex? When x is 1, what is f of x? F of x will be 2 minus 4 plus k. What is k? K is minus 30. 2 minus 4 minus 30. We are finding f of 1. F of 1, put x equal to 1. 2 minus 4 minus 30. So this is minus 2 minus 30 minus 32. So when x is 1, y is minus 32. So this value is minus 32. Okay. So the vertex is the minimum value of f of x. So this is the minimum value. So the dotted line is drawn through the midpoint. When you say axis of symmetry, the dotted line is drawn through the midpoint and the vertex is the lowermost point. How do you find? It is nothing but the y coordinate of x. When x is 1, what is y? So when x is 1, what is y? Minus 32. So minus 32 is the minimum value of f of x. I hope you have understood these problems. We will discuss more problems in the next class, in my next video. I hope you enjoyed solving these kind of competency based problems where we apply the concepts rather than just use merely the formulae. Okay, I want you to practice many such problems so that you have become proficient in competency based problem solving. So until next time, it is goodbye and thank you for watching my channel. Do not forget to share, like and subscribe. Thank you.